This problem says the rate at which people enter an amusement park on a given day is modeled by the function e, defined by this function right here. Then it says the rate at which people leave the same amusement park on the same day is modeled by the function L right here. Both E of t and L of t are measured in people per hour, and time t is measured in hours after midnight. These functions are valid from, and t is in between 9 and 23 inclusive, the hours during which the park is open. At time t equals 9, there are no people in the park. Part A says how many people have entered the park by 5 p.m. where t is equal to 17. Round your answer to the nearest whole number. Before we start the problem, I want to just enter E of t and L of t into our calculator. So we're going to press y equals. Okay, so there's our E of t, and then we're going to put L of t as our y2. Okay, so we have y1 is our E of t and y2 is L of t. And for part A, since E represents the rate at which people enter a park and E of t is measured in people per hour, when part A says how many people have entered the park by 5 p.m. or t equals 17, that means we're going to integrate E of t from 9 to 17, and that will give us the number of people who have entered the park. So I set up the integrals. We have the integral from 9 to 17 of E of t dt. So on our calculator, we're going to press math right here, and then we want 9 for the integral. So we type in 9 to 17, and we put E of t as our y1, so we'll call up that function. So I'm going to use alpha trace, and right here's our y1. So you get 6004.270, and the problem says to round your answer to the nearest whole number. So we get 6,004 people. Part B says the price of admission to the park is $15 until 5 p.m. After 5 p.m., the price of admission to the park is $11. How many dollars are collected from admissions to the park on the given day? Round your answer to the nearest whole number. To find how many dollars are collected from admissions, we're going to take the price of admissions times the number of people who enter the park during that time period. So we have up until 5 p.m., price of admission is $15, and then after 5 p.m., your price of admission is going to be $11. So let's go ahead and set that up. So here we have $15 times, and it's the integral from 9 to 17 of E of t dt. So that's the number of people who are going to enter the park from 9 a.m. till 5 p.m. And then from 5 p.m. till the park closes, when t is 23, your price of admission is only $11. So here I have 15, and then I used math 9. We're going to enter 9 to 17. E of t is our y1, so we'll call up that function alpha trace. Then we're going to add 11, and then do math 9. And we have 17 to 23, and then we're going to call up the y1 function again. So we get $104,048, and then it says 0.165, and we're asked to round to the nearest whole number. So our answer is $104,048. Part C says let h of t equal the integral from 9 to t of e of x minus L of x dx for t between 9 and 23 inclusive. The value of h of 17 to the nearest whole number is 3,725. Find the value of h prime of 17 and explain the meaning of h of 17 and h prime of 17 in the context of the park. Here's the given function for h. You have h of t is the integral from 9 to t of e of x minus L of x dx. To take the derivative of h, because this is an integral and we're taking the derivative of it, we're going to apply the fundamental theorem of calculus. So we're going to take this t and we're going to plug it in for the x's, and you get e of t minus L of t as your h prime of t. H prime of 17 is then going to be e of 17 minus L of 17. E of t is our y1, L of t is our y2. So we're going to call up these functions. Make sure you're selecting y2 for your L of t, and you get negative 380.281. Okay, so here's our answer for h prime of 17. To finish the problem, it says to explain the meaning of h of 17 and h prime of 17 in context to the park. And so right here it says h of 17 is 3,725. So our meaning for h of 17 would be at time t equals 17, there were 3,725 people in the park. For h prime of 17, I wrote it out. The number of people in the park was decreasing at a rate of 380 people per hour at the time when t equals 17. So I just wanted to point out that right here, because h prime of 17 was negative, that's why we use the word decrease. Make sure when you have a rate, you have your units. So this one was specifically people per hour, and then also specify when that occurs. And so this one obviously occurs when t is 17. Part D says, at what time t, where t is between 9 and 23 inclusive, does the model predict that the number of people in the park is a maximum? To find where you have a maximum value, you're going to set that derivative, which we know the derivative equals e of t minus L of t. We're going to set that equal to 0 to find our critical value. Okay, so I pressed y equals. E of t is our y1, L of t is our y2. So I'm going to actually call up these two functions where e of t comes first and then we're subtracting L of t. So I have y1 minus, and then I'm going to select y2. So we're going to work just with this y3. Right now y1, y2, and y3 all have their equal signs highlighted. I'm going to unhighlight y2 and unhighlight y1. And by doing that, we're just going to see the graph of y3. Go ahead and hit window, and we're going to change the window. So I'm just going to try negative 50 to 50 for the x min and max, and also for the y min and max. And so right here you can see that the function e of t minus L of t is crossing the x-axis. So we just want to find where this 0 is occurring. So I'm going to do second trace 0. When you're doing so, make sure you're watching your x values and your y values. You can see right now we're over 6, and then I'm way up at 248. So I'm going to keep arrowing right. And you can finally see that this y value is starting to come down. And right there. So if I arrow left, you can't see it, but the cursor is currently up at a height of 186. So I'm going to make that my left bound. So I'm going to press enter. Now we're going to arrow right, and you see that the y value is now negative 34. So now we're right of the 0. So press enter, and then press enter one more time for our guess. So you get x is equal to 15.795. That's going to be where our maximum occurs. And one last thing, t is equal to 15.795. And that does fall in between the hours that the park is open, between 9 and 23.